Hello, this video is to help you with the graph portion of the density changing with size lab. So first thing, you should have filled out your purpose before you started. And then you should have measured the length of the rod in centimeters. And I forgot my units. And then you should have measured the mass in grams for each of the rods. And then after you measured the length and the mass, then you should have calculated the volume by taking the length and multiplying it by 1.13 to get the volume. And then after calculating both the mass and the volume, you should have taken the mass and divided it by the volume to get the density. Now I found that for each of my rods, when I took the mass and I divided it by the volume, I got approximately 19.3 for all of them, which should help me figure out the identity of the rods. So because the density of my rods was 19.3 and the density of gold is 19.3, I can conclude that my rods are probably made out of gold. So now in order to make this graph, along the left y-axis, I am going to plot my mass points. And along the x-axis, I'm going to plot the volume points. So I'm going to treat this as 1 point, okay? So I'm going to go over to 3.8 cubic centimeters. So that's going to be about a little bit more than halfway between 3 and 4. And then I'm going to go up to 74. Now I have to label the y-axis with numbers that make sense for me. So because my values are all between 74 and 160, I am going to label my y-axis. I'm going to start with maybe 65. And I'm going to count by fives. 65, 70, 75, 80, 85, 100, 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 160, 165, and 170, which, I only need to go to 160, so I'm okay. And I should add a title to my graph, since the purpose of the lab is to find out the identity of the substance, I can write density of unknown substance. Now, by the time you are making the graph, hopefully you have identified if your substance was PVC, aluminum, brass, or Tecaform. Okay, so again, I'm going to go over to 3.8, and then I'm going to go up to 74.15, so that's going to be maybe just below 75. I'm going to plot my point. Now, these points are not going to be perfect, but they should be close, okay? All right, now I'm going to go over just a little bit past 5. And I'm going to go up to 100. So again, you would be using whatever data you got based on your rods. You did not have gold, so your points will not be the same as mine. I'm going to go over a little past 8, and then up to 157. 157. Around there. 7.3 to 141, 6.5, 126, 5.7, and 111, around there. Okay, so if I notice my dots kind of form a diagonal line. Again, it's not perfect, but it's pretty diagonal. Your graph should show a diagonal line. The slope of your line should equal the density of the material. So the slope of the line is how steep the diagonal is, okay? Choose 2 points on the line and write their coordinates, x1 and y1, and then x2 and y2. Use the formula below to help you find the slope of your line. What are your coordinates? So I'm just gonna use the first 2 coordinates. So my x value is the 3.8 for 2. That's my x1. And my y1 is 74.15. Okay. And then my second point is 5.198 and 100.32, which is my x2 and my y2. Now this is where we're going to do a little bit of math, okay, in order to calculate the slope of this line. So let me show you what that looks like. So I'm going to take my y2 value, that's this one, okay, and I'm going to do the math down here. I'm going to write 100.32, and I'm going to subtract my y1 value, which is this one, 74.15. And I'm going to do that over my x2, so that's 5.198 minus 3.842. And so if I do that math on a calculator, I can type in that 100.32 and minus 74.15, and I will get 26.17. And if I do this 5.198 minus 3.842, I will get 1.352. And so if I take 26.17 and I divide it by 1.352, I will get 19.36. I kind of ran out of space there. So it says, what is the slope of your line? The slope of my line is 19.36. 19.36. Does this match the density of my material? Well, the density of my material was 19.3. So I would say, yes, it does match. It's off a tiny bit, right? 0.06 off, but that is close enough. And I can also add a diagonal line to show that the slope of this line is about 19.36. So I can kind of sketch how that line would go. Okay, and that is how you complete the bottom half of this worksheet.